So we're going to start off today just reviewing what we learned last week on Thursday. So we've just started this chapter on sequences and exponential functions, and I want to review what we went over. So what I'm asking you to do in this problem, and you'll be working on your own here, so make sure you pay attention. I'm going to ask you to read this sentence right here, and you're going to fill out the table and make a graph of the situation. So let's read the sentence together and I'll get you started on this. It says a bacteria colony starts with 5 cells. Starts with 5 cells. Is that going to show up on our table someplace? When we say something starts, we're talking about an x value of what? X value of 0. So our starting value was 5 cells. So go ahead and put a 5 next to the 0. The other piece of information they give us is it says the number of cells doubles every hour. How do you double a number? If I give you a number like $5.23 and you want to double it, what are you going to do in your calculator for $5.23? Times 2. Doubling something means multiply it by 2. So that's going to give you your rule for how we get the rest of these numbers. We're going to multiply times 2. So go ahead and use that rule, and you're likely going to want a calculator at some point because these numbers are going to get quite large. If you don't have a calculator, there's some in the back of the room there, so go ahead and grab one. Use that to fill out the table and then to fill out the graph, and then we'll come back together and talk about this. In the meantime, I'm going to be putting you guys into groups because we need you guys in partners for what we're going to do next. So go ahead and fill out that table and that graph, and we'll come back together in a second. All right, let's make sure we're all on the same page here. For multiplying by 2 each time, did you guys come up with 10 for the next one? 5 times 2 is 10. 10 times 2 is 20. 20 times 2 is 40. 40 times 2 is 80. 80 times 2 is 160. And then we can graph these points. I need to look carefully at my y-axis here. Notice that it seems like each of these tick marks is going up by 10, right? 10, 20, 30, 40, 50, 60. Yeah. So 5, 0, 5 would be about there. 110 would be about there. 220, 340, 480, 5, 160. And remember, when you connect these, let's connect them with a nice smooth curve. We're not going to connect them like a dot to dot with straight lines. They're going to connect with a nice smooth curve. And this situation is representing bacteria cells in a bacteria colony. Do you think they're going to keep growing past 5 days if we let them go, or are they just going to stop there? You think they're going to keep going? How can what can we put at the end of our graph here to indicate that it's going to keep going? Let's go ahead and put an arrow on there. If you haven't already, please put an arrow on there to indicate that it would keep going and sort of in that same trend forever and ever. Okay. So I want to talk to you guys. Let's look at number 2, and we haven't introduced this yet, but I think you're going to pick up on this pretty quickly. I want to focus on these 4 graphs. Can I get your attention, please? Thank you. Let's focus on these 4 graphs in number 2, and let's focus just on the first set of categories. Linear or exponential? Is this first one linear or exponential? Linear functions make a straight line. Is this making a straight line? Okay, go ahead and circle linear for that one. Let's leave the growth and decay alone for right now. Let's do the rest of them linear or exponential. Second one here, is this linear? It's not a straight line, is it? It's a curve, and it's kind of curving upwards just like our last one. This is a classic exponential curve. What about this third one? Is this linear? Nope. Okay, well then it must be exponential. Now there are other options than those two, but all of these are either linear or exponential. Is the last one linear? Yes, it is a straight line. Look back at the first one. And let's focus on growth versus decay. You think the first two are growth? Well, can you tell me why you think these first two are growth? It goes up. This one's going down though. It's going down, see? I'm trying to be tricky here. What am I doing wrong? What am I doing wrong? You were right. Stick to your guns. You're right. When I decide whether it's going up or down, do I need to be going from left to right or right to left? Left to right, the same way that we read a book in English, right? I need to be going this way. So if I'm moving from left to right, you're right. I am going up. I am going up. So this is growth. So when we're walking our line to determine if it's growth or decay, we always want to be moving from left to right. Imagine yourself walking along that line. And we can see that in these first two, we would be increasing. We're going uphill. So that's growth. And the last two, if I'm walking from left to right, I'm going downhill. That's decay. Okay. We're going to learn some other names for these linear and exponential graphs a little bit later in the period today. So I want you to keep what we did here in mind. On your desk now, you should have a sheet, and I just gave one per team. And it has 5 sequences on it. Right? So you've probably played this game in one of your math classes before where they give you a list of numbers and they ask you what comes next. Have you ever seen this before? So there are actually 10 of these. I've only given you the first sheet. I want you guys to work with your partner right now and see if you can fill in the missing blanks in each of these. Now, I'm going to give you a little bit of a warning that there are some of these that are really tricky. Okay, so do your best. If you get stuck on one and you're not 100% sure how to fill in the rest of them, go ahead and move on to another one. But see if you can find the rule. Sometimes the rule is simple, like you're just adding the same thing over and over again. Sometimes you're multiplying by the same thing over and over again. See what you guys can do with those. I'm going to come around and pass out the second of these. You're going to have 10 of these sequences altogether. All right. Does anybody have any questions what I'm asking you to do? Figure out the pattern and fill in the blanks. And I want you working with your partner as you do this, okay? All right, I'll be around to get you the other 5. I'm super proud of you guys for giving us a shot, and everybody was able to get most of these. Shh. Guys, let's pause the side conversations. I love that you're still trying to figure these out too. Let's talk about them. Does somebody want to volunteer to give me the rule for part A? What were we doing each time in part A? We're doing +3, +3, and +3, and that rule holds through all of these, so it must be our rule for this. So if we keep adding 3, we would come up with 8, +3 is 11, +3 is 14. Did you guys get 8, 11, 14 there for your last 3 for part A? All right, someone help me out with B. B was a little tricky because of the decimals. What are we doing each time here? What's my rule? Multiply by 2 times 2 times 2. That does work. 12 times 2 is 24. 24 times 2 is 48. 48 times 2 is 96. All right. Part C gave a lot of people a lot of headaches. Yeah, I give up. Baker, Megan, what did you guys come up with for part C? What was the trick to recognizing this one? Yeah, the 0, 1, 4, 9. Yeah, these are all perfect squares. 0 times 0, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. So this would be 4 times 4, which is 16. This would be 5 times 5, which is 25. This would be 6 times 6, which is 36. Did you get those same numbers? Ah, okay. I'm curious. So how did you, Jason? How did your group do it? What did you notice? Say it again.
That's not what I was thinking.
Help me out. Were you adding or were you multiplying? You were adding, and how much you for? So for this first one, you did plus 1, and then plus 3. Okay. So you were increasing by 1 here, and then you increased by 2 more than 1. So basically, you're adding 2 to the thing that you're adding each time, and that does work. And give the rest of these. That's what you guys. Is that what you guys did too? Okay. What do you think? What do you think about this other way? You like your way better? Okay. So however you do it, we came up with the same thing. That's awesome. All right, guys, your attention, please. Shh. For part D, what were we doing? What's our rule here? Plus 1.5. And that works. So plus 1.5 will get us, where would that get us? 8, 9.5, 11. All right, did anybody figure out part E? Guys, I need your attention, please. Stop the side conversations, please. Yes. So you're thinking this is plus 0, and this is plus 1. And then this is plus 1. You add these together to get plus 2. Ooh, that's tricky. 1 plus 2 is 3. So you're going to do plus 3 here. So then you're going to, so I think you're going to add 5 for the next one. Oh, interesting. Hey, put that phone away, please. Thank you. That totally works. Huh. So you're looking at the last 2 things you added, you're adding those together to figure out what you're going to add the next time around. So next time we're going to add 5 to this, and that's going to get us 13. And then what am I going to add this time? I'm going to add 3 and 5 together. So I'm going to add 8, and that's going to give me my next one, which is 21. That is really interesting. That is not what I had in mind. Guys, look up here real quick. This totally works, and I applaud you. Same idea, though. Hey, can I get your attention, please? Anara, look up here for a second, please. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 is 21. 13 plus 21 is 44, which is exactly what you guys got doing your way too, isn't it? That's interesting. So you're actually doing, you were adding the last 2 things you were adding. I was just adding the last 2 things together. This one has a name. It's called Fibonacci sequence. All right. What are we doing here in F? What's the pattern? Minus what? Can I get you guys to stop the side conversations, please? Can you stop the side conversations, please? And pay attention. It's really distracting. Let's stop the side conversations, please. From 9 to 7, what am I doing? Minus 2. Minus 2. Minus 2. So we're going to go minus 2 will give us 1, minus 2, negative 1, minus 2 would be negative 3. Thank you. For G, what was our pattern? Divide by 2. So divide 12 by 2, you get 6. Divide 6 by 2, you get 3. What is 3 divided by 2? 1.5, or as a fraction, that would be 3 over 2. Either way is fine. All right, part G. What are we doing here? For part G. From 27 to 9, what am I doing there? Divide by 3. And we talked about a different way of doing it. Jason, what was the thing that I said we could do instead of dividing by 3? What did we say instead of dividing by 3? We said we could multiply it by something instead. By 1/3. Multiplying by 1/3 is the same as dividing by 3. And I actually find that easier when you get to here because 1 times 1/3 is just 1/3. 1/3 times 1/3 would be times 1/3. You multiply the ones together, you get 1. You multiply the threes together, you get 9. 1/9 times 1/3. Multiply the ones together, you get 1. Multiply the 9 and the 3, you get 27. All right, part I. Anybody figure out what was going on here? This was the hardest one for me. Until the 18, it was pretty clear. There's a couple ways to do this. Anybody have any ideas? What did you do, Erica? +4. So from here to here, that's -6. And then you add 4 to -6 and you get -2. And you add 4 to -2 and then you get +2. And then you add 4 to +2 and you get +6. That works. You add 4 to 6 and you get +10. So if I add another 4, I'm going to get +14. Does that sound right? So 18 plus 14 is 32. And then +14, another 4 would get me +18. 32 and 18 is 50. And then we just added 18, so +4 would be +22 this time, gets us to 72. I believe so, unless I did some math wrong there. Is that what you got? All right, on the last one, we need to move this along. If you didn't get this, that's okay. It's ×2 is what we're doing here. ×2, ×2, ×2. So 10 times 2 is 20, times 2 is 40, times 2 is 80. We all got those filled out? Okay. Your team got a sheet a second ago. We're going to do an example in this, and then your team's going to do one of these on your own. So I need you guys to pay close attention as we do this together. Okay. So one person in your team is going to do the table, and one person is going to do the graphs. So get the sheet in front of one person with their pencil out. We're going to go over sequence A together. Then I'm going to assign another sequence to your group. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 groups, which means we should end up getting all 10 of our sequences. Just go ahead and join in with this group here. Okay. So could you guys please, whoever's got the paper in front of them right now, put A right here. All right, n equals 1. Let's fill this out. This would be 2, 3, 4, 5, 6, 7, 8. And that's going to be the same for all of your sequences. Remember, I'm going to assign another sequence to you, so make sure you're getting your questions answered now. Now, this is some weird notation. We'll talk about this notation next class, but this is the sequence, okay? So for part A, the first term, T stands for term. T stands for term. What is the first term in A? The first term is -4. So term 1 is -4. What is term 2 for A? -1. Term 3 was 2. Term 4 was 5, 8, 11, 14. And we're going to have to figure out one more term for A. So hopefully we know what our pattern was. Do you guys remember what our pattern was for A? Plus 3. So what's my last term going to be? Term 8 would be 17. All right. Whoever just filled out that table, pass the paper over to the other person in your group. We're going to graph these now. All right, we're going to graph this just like it was x, y coordinates. So x is 1, y is -4. So I'm going to go 1 and -4, and I'm going to draw a point at 1, -4 here. So go ahead and draw me that point right there. Our next point, I can't show it on the screen and the graph at the same time. Here we go. 2 and -1. So go 2 and -1. Then we got 3 and 2, 3 and 2. Then we got 4 and 5, 4 and 5. We got 6 and 11. No, sorry, we got 5 and 8. Skipped one. 5 and 8. Then 6 and 11. And then 7 and 14. And that's all the space we're going to have for on this graph. And we'll go ahead and draw that line. And now we're done. Okay. So I'm going to have you, along with your team. Oh, there's one other thing that I need to do. Sorry. Whoever drew the graph, in this space right next to it, could you write down what the rule was? Our rule was add 3. Or you could just write +3. Okay, so I'm going to assign you and your team one of these. I'll just give you a letter. On the flip side of this, I want you to do the same thing that we just did, but for a different sequence. Okay. Any questions? I'm just going to give you a couple minutes to do this, and then we'll come back together and I'll give you our final activity of the day. Okay, folks, I need your attention. So let's stop the side conversations. Put the computer away, please. I need your attention. Okay, did you all write your sequence letter nice and big in the space where it says sequence? Did you all write what letter you were assigned there? And have you filled out your table and made your graph? Okay, let me explain our last order of business today. Once we finish with this, then you guys are going to be, you're gonna have some time to work on your homework. You are gonna be turning this in. This is gonna be your points for today. Okay, so you should have one sheet that looks like this for your group. Did I miss anybody's group with this sheet? Please make sure you have your first and last names, or at least last initial, or first initial and last name. I don't know, however you want to do it. Make sure I've got some, either a first name and a last initial, or a last name and a first initial, or both of your names would be the best. Make sure everybody in your group's got their name on there though. Now, there's part of this you guys don't know, so I really need your attention through this. So I'll ask again for the side conversations to be put on pause for a moment, and you guys to look up here, please. We're going to go through part A. So in a moment, you are going to leave your graph and your table out on your desk, and you're going to get up and you're going to move around the room. And it's going to be your job to take notes on the other sequences other than yours, about whether it's increasing, decreasing, about whether it's linear, nonlinear, what the sequence generator is, and this last part, which I'm about to explain to you because you probably don't know what arithmetic and geometric means yet. Can I get you guys to hold on the side conversations, please? Folks, I've asked several times now, and now I'm starting to get a little annoyed. Can you please stop talking? Thank you. So for part A, you're not going to see this one sitting out because it's right up here with mine, but I'm going to walk you through it. This is the one that we did together. Is this increasing or decreasing? Increasing. So could you guys go ahead right now and say increasing for part A? We graphed part A together. Was it linear or was it nonlinear? It was linear. Our sequence generator was plus, wasn't it? We were adding 3. So this is one of the more basic ones, so we can just write plus 3. Now I need to define for you what arithmetic and geometric are. Okay, and we want to get this, actually, is there a space in our packet for this? Why don't we put this right in our packet? You guys got your packets out still? You've got learning logs / extra notes. Let me define for you what arithmetic and geometric mean. So I'm just putting this on the last page of my packet. An arithmetic sequence is a sequence where the rule is to add the same value each time. If we are always adding 5, we are always adding 3. This would also work if you were adding a negative number. So some of you had a sequence where you were subtracting the same thing each time. You could accomplish that by adding another number. So add, and I'm going to go ahead and put in parentheses, or subtract. But you have to be adding the same value each time. Which team had sequence E? Was that you guys? So we figured out a way to add, but were we adding the same thing every time in E? No. So was it arithmetic? No. Awesome. Okay, so keep in mind you got to be adding the same thing each time. Geometric sequences are one where you are multiplying the same thing, the same value each time. And we can also divide, because we can always accomplish division by multiplying by a fraction. Now, it's possible for a sequence to be none of the above, right? For example, sequence E is not adding the same thing each time or multiplying the same thing each time. It would be neither. It's not arithmetic or geometric. So now that we've got those notes, let's go back to sequence A. Was it arithmetic, was it geometric, or was it neither? It's arithmetic because we were adding the same thing each time. We're adding 3 each time. So I'm going to write arithmetic. So I'm going to ask you to put your graph. I'm going to give you a very specific location I'd like to be so that we can easily get around the room here. So could I get folks in this row, could you please put your graphs on the ends of your tables right here? Make sure you don't have anything else right near it. For folks in these rows over here, I'm going to ask you to put your graphs on the ends of your rows over here. And then Bella, Erica, if you guys could put yours on the end of your table where Bella is, okay? You and your partner now need to get up with a folder or a book or something to put behind that check sheet that you were looking at. I need you to move around the room, and I need you to get answers for the rest of these. Was this the one that you did? Okay. So put this out here. So make sure you get all of the rest of them.